2020 question 3 on paper 1 is a composite function question. Is f of g of x the same as g of f of x? So f of g of x, we have to put g of x into f of x. So let's just write them down. F of x is equal to 6x minus 5. So I could put g of x in here. So f of g of x becomes 6 times, so I'm replacing x with my g of x, 6 times x plus 5 over 6, which is g of x minus 5. So I'm going to get x plus 5 minus 5, which is just x. And if I do the same over here, g of x is equal to x plus 5 over 6. If I want g of f of x, I want to replace this x with g of x. So that's equal to, with f of x, it's going to be 6x minus 5. That's the x replaced, plus 5 over 6, which is equal to 6x minus 5 plus 5 over 6, or 6x over 6, which is just equal to x. So, conclusion, they are the same. Part B, we're on to a logs question. The real variables y and x are related by y is equal to 5x squared. And this can be written in the form log of y to the base 5 is equal to a plus b times the log of x to the base 5. So when we change the left hand side using our rules of logs here into, we get the log to the base 5 of both sides. So log to the base 5 of y is equal to log to the base 5 of 5x squared. Now that's a product, 5 times x squared, so that's log to the base 5 of 5 plus log to the base 5 of x squared. The product becomes a sum, so log to the base 5 of 5 is 1, and this becomes the power again. The power is going to go down in front, twice the log to the base 5 of x, and we have it in the form now a plus b log to the base 5 of x. So a is equal to 1 and b is equal to 2. And part 2 of this question, hence or otherwise, find the real values of y for which the log of base 5 to y is equal to 2 plus, and you can see this equation here that we have to show that it's equal to. So we can write the left hand side of this question is what we got our answer to be. And the right, so why don't we start off by doing that? So the log to the base 5 of y is this guy that we just got, 1 plus twice the log to the base 5 of x has to be equal to 2 plus log to the base 5 of 126 over 25x minus 1. If I bring the numbers to the right and the logs to the left, I'll get twice the log to the base 5 of x minus log to the base 5 of 126x over 25 minus 1 equals 2 minus 1, which is 1, and this is the difference of two logs, so that's going to be a division. So twice log to the base 5 of x over log to the base 5 of 126x over 25 minus 1 equals 1. So if I change this around to get the base, I can say 5 to the power of 1. So if I say, well, I can change this to x squared. Why don't I put that back to x squared? So I have the log to the base 5 of 1 over the other, which I can write like this. I have x squared on top, and on the bottom I have 126x over 25 minus 1. So this whole thing is equal to 1. 5 to the power of 1 is equal to this. 5 to the power of 1 is equal to 5. So x squared over 126x over 25 minus 1 is equal to 5. Is this going the right way? Let's see where we get with this. cross multiplying, I'm going to get x squared is equal to 5 times 126x over 25 minus 1. So if I multiply out the right, x squared is equal to 126x over 5 minus 5. If I multiply the right hand side out, and now multiplying by 5 and bringing everything to the left, I'm going to get 5x squared minus 126x. The 5 disappears, 5 5s are 25, minus becomes a plus. 25 is equal to 0. I think this does factorize. Let's have a look here. 5x times x. 25 by 5 is 125. 25 by 1, that's going to give, no, the wrong place. If I put the 25 here, I'm going to get 125x, and 1x is 126x, minus and a minus, so x is equal to 1 over 5, or 25. That factorizes nicely, and we asked to solve for find the real values of y, and that was earlier on the question we were given y is equal to 5 times x squared. So y equals 5x squared. So for a fifth, 5 times 1 over 5 squared. So that's going to be 1 over 25. 5 times 1 over 1 over 5. 5 times 1 over 5 squared. Or we have x to 25, y is equal to 5 times 25 squared. 5 times 625 is 3125. And there are the two solutions for y. So quite a tricky logs question. There's a lot of substitution back in and stuff, but definitely doable.